Hi, I'm Mingyuri, and this is my advanced topics in physics first oral presentation. My, my current research topic is diode pumped session vapor laser and MOPA polarization beam combining. The outline is as follows. First, I will introduce diode pumped alkali laser. It is called DPAL. And next, the researchers who previously conducted research on DPALs are summarized in a table. And then I will explain the limitations of the previous study and the differences between my research, and lastly, I summarize the previous presentation. Alkali atoms include rubidium, potassium, cesium, etc. Among them, I used cesium as a gain medium. Cesium atoms has a 3-level energy as shown in the figure. The pump wavelength is 852 nanometers and the lasing wavelength is 894 nanometers. In this process, electrons are relaxations from the first excitation level to the second excitation level by a buffer class used with cesium. As you can be seen from the pump and lasing wavelengths, cesium has a quantum efficiency of 95%, which is quite high. And then there are several reasons why DPAL is attracting attention. When used as a gain medium, cesium is contained in a quartz cell with AR coating as shown in the figure on the left. Cesium has a melting point of 28 degrees and is used as a vapor when used as a gain medium. As you can see in the graph on the right, the highest concentration of alkali atoms below 200 degrees in cesium. Gas gain mediums is a very important feature because it can be very homogeneous and has excellent optical quality with reduced aberrations, observing and scattering centers and refraction index fluctuations. And reduced summer problem is one more advantage of a gas gain medium. The summer effect is existing, for example, in solid state lasers cause aberration and thermal lensing that degrade the beam quality. The thermal problems in a gas gain medium can be significantly reduced or even eliminated by flowing the gain medium. Operating wavelengths of our or DPALs lie within atmospheric transmission windows, and which is essential for any direct energy application of DPALs in atmosphere. DPAL is divided into longitudinal and transverse structures depending on the pumping structure. The longitudinal structure is not suitable for using multiple LD but has high efficiency. Conversely, the transverse structure can pump high power but is relatively inefficient. This is the result obtained by other researchers or summarized above. In 2009, 62% and 68% of the CW type have the highest efficiency, and in 2016, 1.5 kilowatt output was oscillated using potassium. However, there are some problems with achieving high output in DPAL. When the laser oscillate is performed, the overlap of the pump light and the cavity mode is high, so the efficiency and output are high, but there is a limit to maximize mode overlap. Next problem is cell contamination. If the laser passes through a window where the cesium is condensed, heat increases in that area and the window is damaged. This is a damage point. But the amplifier can be used in other ways to achieve the output. MOPA can amplify the seed beam to achieve high output power. This is the research using MOPA in DeepR are summarized as follows. Some of the notable studies are as follows. This study amplified 10 milliwatt signal using 18 watt pump power. However, as shown in the graph above, the amplification is relatively small because the overlap between the pump and the seed beam is not large. The next study is an experiment on small signal amplification. You can see that the amplification is quite large compared to the previous data. This is because the spatial overlap between the pump and the seed beam is maximized by using an optical fiber. So this is my experimental setup. Previous studies constructed MOPA using a single channel. However, my experiment setup separates a signal using polarization, amplifies it, and then combines it to obtain high power. This experimental setup can maximize the spatial overlap of the beam as in the previous study. In addition, it is possible to reduce the thermal load on the cell and to expect to a higher power than the conventional single MOPA. In summary, DeepR has attracted attention worldwide because it has many advantages. Example, high quantum efficiency, scalability to high power, reduce thermal problem, etc. And furthermore, diode pumped alkali amplifier is proposed to achieve high power. And finally, my experiment using MOPA polarization beam combining can be achieved while reducing the problems. Thank you for listening my presentation. 몇 분이지?